Hi, my name is Chris Shapiro. I am the sales manager for SHW, and today I'll be presenting about a new design layout concept around the hammer mill island for pellet plants. For those of you who are not familiar with SHW, we are a storage and handling equipment manufacturer that centralizes in silos and silo reclaimers. Hammer mill island is an area in the pellet plant industry that I, as well as some other people, would say still has some room for growth and design. Normally, end users tend to see a big dollar sign and a heavy maintenance schedule every time the statement Hammer Mill Island comes up. But with our new layout concept, I believe that SHW can help supply end users with a more cost-effective and less maintenance solution. Hammer Mill Islands are a very important section of the pellet plant that can make or break the final creation of wood pellets by how the Hammer Mill Island processes material downstream. With that being said, there's many different ways to set up a hammer mill island to help process material downstream. For our purposes today, I'll be touching on a few of the classic layouts before talking about our new layout concept. These are a few examples of hammer mill islands that are currently in the industry that handle dry or green wood chips to get them sized down from a 4-inch chip to a 6 to 2 millimeter chip. Major cons, of course, the biggest con is a very expensive initial capital cost. There's also a lot of maintenance work needed to handle multiple hammer mill lines along with multiple drag chain conveyors and surge bins. Material being fed into each hammer mill is being surged due to the drag chain conveyors. This can cause troubles for sizing the material down to the specific chip size. The future expansion of the capacity per hammer mill line is also limited to the original design. Of course, there are many more points about these hammer mill islands that could be stated for pros and cons, but these are a few of the troublesome items I would like to discuss today. Here's an isometric view and top view of the new hammer mill layout I'll be discussing in detail. The new layout utilizes our SHW rotor discharge system as a large surge bin that equally feeds using screw conveyors to a specific discharge rate into each hammer mill line. Hammer mill system can be designed to feed directly over the downstream conveyors or utilize another screw conveyor that is shown here to help discharge material equally out of the hammer mill system. To explain why using the rotor discharge system adds such good pros to the hammer mill island, I would like to break down the rotor discharge system from point to point. The rotor discharge system is to be thought of as more of an agitator than a silo reclaimer. The rotor system spins and agitates the material within the silo using 2 drag arms to disperse material into the discharge screw troughs. These discharge screw troughs and screw flights are designed by our wonderful engineers at SHW to discharge material at a specific capacity per discharge screw. Variable frequency drives, or VFDs, can be added to the discharge screw to adjust said discharge rates if needed. Our rotor discharge system is capable of handling a high variety of screw arrangements to allow a specific feeding to the downstream process. Each screw can be designed to a specific discharge rate out of the silo, even if the screw conveyors are at different discharge rates. This screw layout is one of the most popular screw layouts because it has 1 screw feeding material to a downstream process and 1 discharge screw acting as a dump screw to clean the entire silo into a concrete bunker for maintenance purposes. This screw layout is designed to discharge material at a very high discharge rate utilizing 2 twin discharge screws on each side of the silo. This layout also has a dump screw feeding into a bunker to empty out the silo if needed. This screw layout is what we would use for our hammer mill layout concept, equally feeding multiple hammer mill lines at the same time while still having the simple ability to turn off 1 discharge screw to a hammer mill line and continuously run the other 3 lines. This layout shows the maximum 5 discharge screws we can handle out of our rotor discharge system. This is always a good for an additional future expansion for downstream process lines. I will explain on my next slide. The rotor discharge system has a unique capability of adding future expansion discharge screws out of the bottom of the silo without having to retrofit or replace any major parts of the system. This is a great addition for any end user that expects a future capacity change in the near or far future. Discharge screws out of the rotor system can also be designed to extend out to long lengths to hit any downstream process point. This helps for any future expansion lines that have to get around old pieces of equipment that can be in the way or any uneven downstream process points. Here shown are a few examples of a 3D rotor discharge system with multiple discharge points out of the silo. The example silo on the left shows how we can feed 4 discharge screws onto a straight downstream process point. The third example silo from the left shows how we can lift these rotor discharge systems to a height that will allow them to be more economical for a plant layout. One additional item that we use alongside with our rotor discharge system is our relief wedges. These relief wedges are designed to keep the material free-flowing enough to allow the material to not cling to walls of the silo or create any bridging problems within the silo. The quantity of relief wedges that are used in the silo are calculated by the material specifications in silo diameter and height. This very brand new video will show you how long the relief wedge system has been used at SHW and the power and detail of why the relief wedges work for our rotor discharge system.
Simple tests. In the first test, we used 2 small bins, one of them equipped with areas of rough sandpaper, the other one a smooth inner surface. After filling of both bins with rice, the test shows that the discharge of the rough bin performs uninterrupted and fast, while the smooth bin shows bridge building and blockages of the material flow. This does not at all conform to the common conception, and one might think that the theory of rough silo walls cannot be used for bulk products as wood chips, bark, fibers, or filter cake slurry. We prepared a second test with wood chips and larger bins and got the same results as before. While the discharge of wood chips from the bin with relief cones was uninterrupted and material bridges which were starting to build up collapsed frequently, the smooth bin blocked several times.
Here are a few shots of our relief wedges uninstalled and installed. These are a few general technical specification numbers for the rotor discharge system on a minimum and maximum design. Discharge capacity: single discharge screw can max up to 10,500 cubic feet per hour. Tandem or twin discharge screw can max up to 21,250 cubic feet per hour. Discharge screw dimensions: discharge screw length can max up to 40 feet long. Discharge screw diameter is minimum of 0.5 feet to a maximum 3.25 feet diameter. Silo storage volume: we have a minimum of 750 cubic feet to a maximum of 35,500 cubic feet volume. Silo dimensions: we have a minimum of 10-foot diameter to a maximum 23-foot diameter. Minimum 10-foot height to a maximum 90 feet height. Wear protection: as an option for very abrasive and corrosive material, a special tailored design of stainless steel or Hardox wear protecting welding or infinite shield tiles or ceramic wear tiles can be installed for added extra protection. So why is the new hammer mill layout better than the old hammer mill layout? First off, it is a lot less of a capital investment / cost for the end user to go with the rotor discharge system layout than the old classic multiple drag chain conveyor and hammer mill lines. The rotor system is designed to feed each hammer mill line at a specific discharge rate while being able to use a VFD to change said rate if needed. It also discharges material to the hammer mill without any surging versus a direct feeding drag chain that would surge material into the hammer mill. The new layout has the ability to shut off one discharge screw to a hammer mill line and continuously run the other 3 lines if needed on an emergency basis. Some of the old classic layouts can do the same, but this is not without any additional costs of equipment. The rotor discharge system can have an additional discharge screw installed at the bottom of the silo for future expansion of hammer mill lines while utilizing the same rotor discharge system. Last but not least, of why the new layout is better than the old layout is the very low maintenance needed for the rotor discharge system versus drag chain conveyors or multiple surge bins. Here at SHW, we want to design the most operational and cost-effective solution for our end user customers. Thank you for your time today, and I look forward to answering any questions about SHW's new hammer mill layout concept for future pellet plants.